All right, this video is a review for the quiz on the 3 lessons we've done so far in this unit. Lesson 1 was called Operations with Radicals. Lesson 2 is called Geometric Mean. And Lesson 3 was the Pythagorean Theorem. Okay. Now, if you haven't done so, I want you to try this on your own first before you watch the video. Okay, so try this on your own before you watch the video. Okay, for numbers 1 through 8, simplify each expression. Write your answers as exact values. So that means do not just go in your calculator and type the square root of 48 and get a decimal. Okay, that's not what I want for these. Okay, I want you to simplify these and give exact answers. So they're going to be in radical form. Okay, so for number 1, simplify the square root of 48 using the list of perfect square numbers. Okay, now if possible, try to find the biggest one. That's a factor of 48. If not, then it's not going to be simplified enough, and you're going to have to do the process again, okay? So find the biggest number from this list that's a factor of 48. Again, try it on your own first. If you're doing it as you watch the video, pause the video and try to find it yourself. But the answer is going to be the square root of 16, okay? So for my next step, I'll write the square root of 16 times the square root of 3, and the square root of 16 is 4, not the square root of 4. A lot of people will say the square root of 16 is the square root of 4, and that's not correct. The square root of 16 is just 4. So 4 square root of 3 is the answer. Number 2, simplify the square root of 180 from the list of perfect square numbers. Oh, and by the way, number 1, when you write your answer, make sure you put the number first and then the square root. Do not put the square root first. The number comes first, then the square root. Number 2, simplify the square root of 180. So again, pause the video if you haven't done this yet on your own. To find the biggest square root that's a factor of 180 from this list of numbers. It's going to be 36. So it's square root of 36 times square root of 5. And the square root of 36 is 6. So 6 square root of 5. Again, the number comes first and the square root. Number 3, you're going to have to add these together. Now, the radicands, the number under the radical, that's not the same right now, but if you simplify them, they'll probably end up being the same. So what I mean by that is simplify the square root of 12. You're going to use square root of 4, square root of 3. And then simplify the square root of 27. You're going to use square root of 9, square root of 3. Now let's clean up the perfect squares. Let's make the square root of 4, 2. So 7 times 2. And let's make the square root of 9, 3. So 2 times 3. Let's make the first term 14, square root of 3. Let's make the second term 6, square root of 3. And now the radicands are the same. Each radicand is 3. So you can add these together, just like you would do if it was like 14x plus 6x. You would make that 20x. We're going to make this 20 square root of 3. Number 4, subtraction. The radicands are not the same. Let's simplify and see if you can get them the same. So we'll simplify the square root of 20 down to square root of 4, square root of 5. We'll make the square root of 4, 2. So 3 times 2. Let's make the first term 3 times 2 is 6, square root of 5. And so just like if you did 6x minus 3x, it we're going to do 6 square root of 5 minus 3 square root of 5 to get the final answer as 3 square root of 5. Number 5, multiplying. You can multiply where the radicands are not the same. So you can do 5 times 7 is 35. And you can do square root of 2 times square root of 8 is square root of 16. Okay, the square root of 2 times the square root of 8 is the square root of 16. Now, you can simplify the square root of 16 down further, because the square root of 16, that is on my list of perfect square numbers. It's just 4. Okay, 35 times 4. (35 times 4 is 140. Number 6, another multiplication problem. Let's multiply 4 times 10 to get 40. And then let's multiply square root of 6 times square root of 8. And that would be square root of 48. 1 second. Okay, so what I did so far was I just did 4 times 10 is 40. Then I multiplied the radicals together, the square roots together. Square root of 6 times square root of 8 is square root of 48. And now we'll simplify the square root of 48 from the list of perfect square numbers. It's actually the same as number 1 on here, believe it or not. So I'll just do that quickly. 40, square root of 6, 16. Square root of 3. Square root of 16 is 4. So 160 square root of 3. Okay. Oh, 2 more like this, actually. You have 14 problems total in this review. Division. So you cannot have a square root in the denominator. Okay. So for number 7, what we're going to do is we're going to do what's called rationalizing the denominator. I am going to multiply by the square root of 5 over the square root of 5. Because if you multiply by something over itself, it's like you're multiplying by 1. And when you multiply by 1, you don't change anything. So my denominator, square root of 5 times the square root of 5 is just 5. Okay. The square root of any number times the square root of the same number is just the number without the square root. So square root of 7 times square root of 7 is 7. Square root of 19 times square root of 19 is 19. Square root of 57 times square root of 57 is 57, and so on. Because if you think about it, square root of 5 times square root of 5 is square root of 25, which is 5. And now multiply the numerators together. If you notice the square root of 16 is 4, you can just go right to 4, square root of 5. And just double check and see if you can simplify this anymore. So can you simplify the fraction 4/5? No, so just leave it like that. And then that's the answer. Okay, so moving on to number 8. Simplify 5 square root of 2 over square root of 6. What I'm going to do is I'm going to multiply by square root of 6 over square root of 6. This one's going to be a little harder than the previous problem. So my denominator is going to be 6. Square root of 6 times square root of 6 is just 6. My numerator is going to be 5 times square root of 12. And now you're going to simplify the square root of 12 using the list of perfect square numbers. I'm going to use square root of 4 times square root of 3. 5 times square root of 4 is 5 times 2. Which is 10. And now you can actually simplify this a little bit more because you have a fraction, 10 over 6. You can simplify that to 5 over 3. So 5 square root of 3 over 3. So if you can simplify these two numbers, you would simplify them. Okay? You leave the square root of 3 alone. For number 9 and number 10, solve for x and y. If necessary, write your answers as radicals in simplest form. Okay? So these are going to be geometric mean problems. Okay, so x is the altitude x. You know what? Let me redo that. Actually, let me redo that real quick. Okay, so I need more room, so I just moved it over. Okay, so like I said, x is the altitude. X is the altitude. The altitude is the geometric mean between the two different sections of the hypotenuse. Okay, so in this case, it'll be the geometric mean between 4 and 10. In general, most of the class did not have problems with problems like this. We had to solve for the altitude. It's getting the leg that's harder on these problems. Okay, so cross multiply x squared equals 40. It asked you for your answers as radicals, so x is going to equal the square root of 40. And you're going to simplify that from your list of perfect square numbers. You're going to use square root of 4. Square root of 4 times square root of 10. And then x equals 2 square root of 10. Okay, so that problem people didn't have problems with, getting the altitude. Okay, so the altitude, in this case x, is the geometric mean between 4 and 10. It's the leg, solving for the legs that gave people problems the other day. So the leg, in this case y, oops, I meant to put it right there. Y is the geometric mean between the portion of the hypotenuse that's adjacent to y and the entire hypotenuse. So after my whiteout dries, I'll do that. Okay, so the leg, in this case y, is the geometric mean between the part of the hypotenuse that's adjacent to it, which is 4, and the entire hypotenuse, which is 14. Cross multiply, y squared equals 4 times 14, which is 56. Okay, let's see which one of these numbers we're going to use. It's going to be 4 again. Y equals the square root of 56. Y equals square root of 4 times square root of 14, which is 2 square root of 14. Okay, number 10, let's start with x. X is the one that people have not been having problems with finding the altitude, because the altitude, x, is the geometric mean between the two different sections of the hypotenuse, in this case 4 and 15. Okay, so x squared equals 60. Simplify that. Square root of 60. Square root of 4, square root of 15. And then 2 square root of 15. Now let's solve for y. Y is the hard one, because the leg, in this case y, is the geometric mean between the part of the hypotenuse right next to it, which is 15, and the entire hypotenuse, which is 19. Cross multiply. Y squared equals 285. Y equals the square root of 285. And let's see which number from our perfect square list works, if any. There might be none that work. None of them are jumping out at me as working for this one. 4, no. 9, no. 16, no. 25, no. 36, no. I think this one's going to be none of them. Yeah, none of these work. So that means you cannot simplify the square root of 285, so that's the answer. Number 11 and 12, solve for x. If necessary, write your answers as radicals in simplest form. You're going to use the Pythagorean theorem for these. So just make sure you do leg squared plus leg squared equals hypotenuse squared. A lot of people might be tempted to do 9 squared plus 15 squared equals x squared. Don't do that because x is a leg. Okay, leg squared plus leg squared equals hypotenuse squared. X squared plus 144 equals 225. I mean 81. I just gave away the answer right there, but it's okay. Okay, x squared plus 81 equals 225. 225 minus 81 is 144. X equals the square root of 144. Remember, you only want the positive answers for these because we're talking about a distance. And that's a perfect square, so x is going to equal 12. Number 12, another Pythagorean theorem problem. So just remember, leg squared plus leg squared equals hypotenuse squared. So in this case, you're trying to solve for the hypotenuse. So 12 squared is the leg plus the other leg, 32 squared equals the hypotenuse x squared. $144. Plus 1,024. That gives you 1168. So x is going to equal the square root of 1,168. Now that's a really big number, so you might have to do this one more than once. But I know the answer ahead of time because I think I looked at it before. Actually, no, I don't know the answer. Let's do it. I think I put the wrong number before. Hold on one second. I put the wrong number up here. My bad. Let me just change that really quick. This number should be 1,168. Let me just let that fix and I'll come back and finish the problem. Check that. I actually did have the right work. That's what I get for trying to multitask and answer emails while making videos. But anyway, so we're at 1,168. And now we have to simplify that. And the biggest one that we're going to use is we're going to use the square root of 16. Okay? That's the biggest one that works. Now, it's possible when you have a really big number like this, there might be a bigger one that works. That is possible. Just keep that in mind. Okay? The perfect square numbers don't end at 225. They keep going. Okay? So in this case, I'll use 16. And the square root of 16 breaks down to 4. So x equals 4 square root of 73. That is simplest radical form that cannot be broken down anymore because the square root of 73 is already simplified. Okay. And now we have two more for number 13, number 14. determine whether each set of measures can be the sides of a right triangle. So what you're going to do is take the two smallest sides, square them, and add them together. And then take the biggest side and square that, maybe off to the side somewhere, and see if they come to the same number. 16 squared is 256. 30 squared is 900. So when you add those together, you get 1,156. And then if you do 32 squared off to the side, that comes to 1,024. Those two numbers are not the same. I'm going to say, no, this is not a right triangle. All right, now this last one here. So again, you have to take the two smallest sides, square them, and add them together. And for this one, you might not know which one of those two smallest sides. So here's what I want you to do. Go in your calculator, type 2 times the square root of 6, and get a decimal. That way you can see which side is the biggest side. 2 times the square root of 6 is 4.898979486. So the biggest side is 7. Okay? So I'll do that one off to the side first because that's easy. 7 squared is 49. Now we're going to have to do 2 square root of 6 squared plus 5 squared and see if that comes to 49 or not. If that comes to 49, then the answer is yes, it is a right triangle. If it does not come to 49, then the answer is no, it's not a right triangle. Okay? So here's my question. What is 2 square root of 6 squared? That means 2 square root of 6 times 2 square root of 6. I'll do plus 25 because we know that's 25. 2 square root of 6 times 2 square root of 6. You're going to multiply the 2's together to get 4. And you're going to multiply square root of 6 times square root of 6. And you should know that is 6. 4 times 6 is 24. 24 plus 25 is 49. So these are each 49. So these are equal. So since they're equal, it means the answer is yes, it is a right triangle. Yes, this is a right triangle. So that is the end of that lesson. I mean, that was a quiz review for the quiz on lessons 1, 2, and 3, operations with radicals, geometric mean, and Pythagorean theorem.